Hey guys, just a video showing off my new water-fed window cleaning filtration setup. The main idea I had behind this was to make something like what's already on the market, a reverse osmosis filter, a carbon filter, and then a resin filter. Not in that order, but yeah, to create something that's on the market, but then also to be able to carry water. This is where the 15-gallon chemical container comes in. We have a Rain Pal 1/2-inch pipe thread to 1/2-inch pipe thread, and there's male garden hose threads, and then this nut here tightens up against those garden hose threads, and then I have a quick release. So just like that, you can see the female threads, 1/2-inch NPT threads in there. On the other end, I have a barb, 3/4 barb to 1/2-inch NPT, and that goes to some 3/4 reinforced hose. Doesn't have to be reinforced, but 3/4 reinforced hose all the way to the bottom. So this just screws on. So my vision here was, when I'm doing lots of storefront jobs, instead of treading them, I would use this setup and just water fed and walk down the street, because it's extremely fast, especially with the wagtail there. I have the resin out right now because I'm tuning the waste ratio on it. So let's go over quickly what this is. So we have our first filter, which is a carbon filter. This is a 10-inch housing. We have 3/4 NPT to garden hose female right here. On these filter housings, you're gonna have NPT threads, usually 3/4. So we have that. This piece you can ignore for now, but this is just a garden hose T. And then I have a pressure gauge here. This pressure gauge has 1/4-inch NPT male threads, and it goes to a 1/4-inch NPT to garden hose. On this end, we have garden hose male to 3/8 barb, and this is a swivel. So if I didn't want to run through my hose, I could just take this off and then put the garden hose straight into there. So that's that end. Next we have 3/4 NPT to 1/2-inch NPT, 3/4 male to 1/2-inch female, I should say. And then we have a 1/2-inch NPT elbow to 3/4 barb, which goes to our 3/4 reinforced hose. Comes up here. And then on our reverse osmosis filter, the one to the side is going to be where the water comes in, and also where the water leaves. So the water comes in here on the side. Okay, this is a 1/2-inch NPT extension. This is a 1/2-inch NPT elbow to 3/4 barb. Then we have 1/2-inch NPT female to 3/4 NPT male. So that's how we're getting, on this Amazon RO, the inlet and outlet ports are 3/4, but the permeate is 1/2-inch. Okay, so we made it in, so our water's coming into our reverse osmosis filter. We have that mounted. I fabricated this. I just cut this plastic on my table saw, and that's how the filter is hanging on. It's basically pushing against this plastic right here. So the water comes in, and the water comes out, so we may as well look at the water, the clean water, the permeate water. So that's coming out of the center post. I have a 1/2-inch valve, 1/2-inch NPT to 3/4 elbow, 3/4 barb. This hose goes all the way down here to our post filter, which is basically the same thing as what we already covered, but we have 3/4 barb 1/2" NPT elbow. We have 1/2" NPT female to 3/4 NPT male, which goes into this. And then on this end, we have 3/4 NPT to male garden hose. And then this is just to my pole. So that's really the bulk of the fittings. There's a bunch of different ways you could do this. You could use PEX. You could use nylon tubing with push fits, which is what Zero does. It's very expensive, but this is, in my opinion, pretty cheap. If I got to do this again, I would probably use 1/2" hose or even 3/8, because 3/4 is just extremely bulky and hard to work with. Okay, so we've seen where the water comes in and where the clean water comes out. What happens to the waste? Because with a reverse osmosis filter, you're always going to have waste. So if we look at the bottom of the cart here, let me move this off. Let's hope that doesn't fall. If we look at the bottom, what do we have? Well, we have in the center post, this would be another way you could get permeate out. Clean water would come out of here. In this case, I'm using the top port and not the bottom one, so I don't need this one. So there's two things you could do. You could either just put a little plug in there, 1/2" plug. In my case, I have a valve, because if I want to drain the filter of water, this is very handy, because it has pressure built up. So sometimes if the filter is heavy and you need to move it or something, you could drain it. And then over here is my waste outlet. So here I have another 3/4 male to 1/2" female NPT. And then I have a 1/2" NPT valve right here. And what you need to do is you need to adjust the valve so that the water you're getting out before your resin filter, the water getting out before your resin filter should be low TDS, or parts per million, ppm, either measurement. Should be very low. If you have more waste coming out, if I open this valve, then I will get purer, I will get cleaner water, but I will have less pressure because more of my water is going to waste. So it's a bit of a balancing act, because you need pressure. If you open that up all the way, you're not going to be able to do any window cleaning. But the more you close it, the higher the TDS of your filter, of your clean water will be. And that's a problem, because if you don't know what you're doing, you could burn out your resin very, very quickly, because you're putting more work on the resin instead of the reverse osmosis. Let's talk about how the pump comes into this real quick. The pump is optional. So I have the pump mounted here. This is a 100 PSI, 1 gallon per minute, 12 volt C-flow pump. Very common for making soft wash buckets and other projects. It accepts 3/8 hose on either side. The water coming out needs to be reinforced because it's going to be pressurized, but your feed water, your feed hose, does not need to be pressurized. It's a little more flexible. Okay. So basically, instead of the water coming in here into my filters, I have the water coming in from the pump. So that way I can run my filters without being connected to a garden hose. Or if I do connect to a garden hose, I can get some additional pressure, because what you're going to see when I hook this up to just garden hose, you're going to see I get about 45 to 50, maybe a little more PSI. But when I turn the pump on, in addition to the garden hose, I'll reach 100 PSI. Now, if I'm just running purely off of my buffer tank, or whatever you want to call it, I'm not going to hit 100 PSI. To hit 100, I really need the additional PSI that's coming from the garden tap. But this isn't really too much of a problem. You only want so much pressure anyway, you only want so much flow anyway, because you don't want to run out of water in your 15-gallon waste tank, or not, your 15-gallon buffer tank. The battery setup, this is a 12 volt 20 amp hour Life Po 4 chemistry battery. Most of these are junk. This brand is the only one that seems to be not completely junk. This is available on Amazon for $60. Why would I go with this battery instead of a lead acid marine battery or some other type of chemistry? Well, this can be mounted in any orientation. It's waterproof. It's extremely light. I believe it's like 6 pounds. So it meets what we're trying to do. And you could also use like a power tool pack from like a drill, for example. You can buy little things that will allow you to get power out of a pack. But this is quite a bit more power than I think I would get, and quite a bit cheaper than getting, you know, a 10 amp hour DeWalt battery would probably run you like 120 bucks. So that's why I went with this. This is a 3D print right here, and on the underneath you can kind of see, basically I have wires running through. The positive goes to the switch, and then if the switch is toggled, it goes to the XT60, and then this is an XT60 male that's waterproof, and then this goes to the pump. I calculated it roughly. I think this battery could run at least half an hour, probably longer, with this pump. This pump doesn't draw that much. If you use a bigger one, you'll burn through the battery much faster. So that's how that works. And yeah, that about does it. So what I could do is I could show you the operation of this. Let me connect it up. So what's kind of cool with these pumps is that there's no check valve that I've observed. So I'm not going to turn the pump on. I'm just going to leave the pump connected to my garden hose, and I'm going to turn my garden hose on. And you're going to hear the water coming through. There's still a few leaks, so just excuse that. It's quite hard to get everything leak proof. Now we can see the PSI coming up. This PSI is going to go to like 50-ish, if I remember. You can hear our wagtail starting to pump a little bit. Yeah, so that's about all we're going to get out of the garden hose. And maybe I could get a little bit more by not connecting through the pump. If I connected the garden hose right here, maybe there would be a little less flow restriction. That's going to be that. And if you really wanted to, you could definitely clean windows with that, like storefronts. That's definitely enough water. See, that's perfectly acceptable off of the tap. And without the resin being in right now, I'm getting like 7 parts per million, maybe 5. So yeah, as you can see, you definitely don't need a pump. And having your stuff leak proof is really important here, because any of these leaks you have, they're going to dramatically reduce your pressure. So watch what happens when I turn the pump on. Watch how the pressure will bump up. My leaks get a little bit worse at higher pressure. So we're over 80. We're probably gonna hit 100 even with the leaks. Yeah, so with the leaks, we're at like 95. You can see we just got water pouring out of this. This is probably more water than you would even need for window cleaning. We would go through a lot of water here. So yeah, that's awesome, especially if you're cleaning something really dirty. Just connect to water and you'll have water, as much water as you can need. So that's that. As you can see, that works really well. You can get a ton of water that way. And you don't have to even use this battery or mount this battery. You could just lug around a marine battery and connect it up. It doesn't matter. I'm just trying to create something like kind of simple that won't be too heavy. So now what I'm going to do is fill this up with water, and I'll show you how that looks when that's running. Okay, here we are on battery power alone. You can see that's excellent flow.